Alright, welcome back. We're going to look at composition of trig functions. And I think before we do that, I want to review how you just do compositions of functions in general. So here's a function, f of x. Here's one that's called g of x, and I have to evaluate g of f of 2. And so we've done these before, and as a reminder, the way to evaluate those is to do the innermost part first, and then work your way out. So the first line of business here is to evaluate f of 2, which is looks like it's 9. So this is 9, and then remember the way compositions work. Since that inner part is 9, now I'm just doing g of 9. G of 9 would just be 1/9. So just keep that process in mind as we do these problems, which look a little more scary, but there's nothing really new, it's just that the functions are different. I've got to do tan of cosine inverse of -1/2. So I always focus by looking at the inside part first. I need to do this first. Now cosine inverse takes ratios, so notice that -1/2 is a ratio, and the answer is going to be an angle. So this part in blue is going to be an angle, and then I'm going to take the tangent of that angle. So cosine inverse of -1/2. Well, since it's cosine inverse, I've got to use my restricted quadrants for cosine, which are the bottom two. And since that is a negative ratio, and cosine is positive here and negative here, I'm going to draw my triangle here where cosine is negative. Now I fill out the sides of the triangle so that the cosine of the reference angle is -1/2. Cosine is adjacent over hypotenuse, so that's a -1, that's a 2, which forces this to be a √3, which means this is 60 degrees. So you can see there's a lot of working backwards in these problems. Now this angle I'm going to put down here is not 60 degrees because remember the name of the game is we start here and rotate until the terminal side is basically where that hypotenuse is. So we're going to put down 120 degrees. So the angle is 120 degrees. So that means so this whole inner part is 120 degrees. Now I got to take the tangent of 120 degrees. So notice we're working our way outwards. Now this isn't so bad because the tangent of 120 degrees, if you just look at the diagram, we don't need to resketch a diagram. It's all been done out for us, right? There's 120 degrees. And so if I want to do the tangent of it, I just do the tangent of the reference angle, which is √3 over -1, or -√3. Let's try another one. Sine inverse of -1/2. Again, I have a ratio, and my whole output is therefore going to be an angle. And so I'm doing sine inverse of -1/2. Well, the restricted quadrants for sine are those two, and sine is negative in this quadrant. And since it's a negative ratio, that's why I need to draw my triangle. And the sine needs to be -1/2. By definition, a sine opposite over hypotenuse, that's a -1, that's a 2, making that a √3, and making this a 30 degrees. But again, I can't write 30 degrees as my angle because I started here and I went down, which means that's a -30 degrees. Some of you might be thinking, well, why don't I write it as going this way, as 330 degrees? The reason is because of these restricted quadrants. Okay, we can only move up and down when we're doing the inverse functions. So this is secant now of -30 degrees. And once again, we do not need to draw a new triangle because the information's here. The secant of -30 degrees, my triangle set up. Secant is the reciprocal of cosine, so it would be 2 over √3. So these are two examples where the inverse part was on the inside. Let's see how the problem looks when the inverse part is on the outside. So I've got tan inverse of sine of 2 pi over 3. So again, as usual, I start with the inside and do sine of 2 pi over 3. So notice that when I do that, I don't need to do restricted quadrants because this is not sine inverse. It's just take the sine of this angle, which we've been doing all along. Very straightforward. 2 pi over 3 is 120 degrees, which means I'll rotate here. So that's 120, meaning this is 60 degrees. Making that a 30, making this a -1, that a root 3, and that a 2. And so the sine of 120 degrees is root 3 over 2. So the answer, remember, this time is a ratio for the inner part, which is root 3 over 2. And of course, we took the sine of an angle. So now I'm doing tan inverse of root 3 over 2. So tan inverse means I need to draw a diagram and I need to restrict the left 2 quadrants when I'm doing tan inverse, because the restricted quadrants for tan inverse are the left 2. And that's a positive ratio, so I'm here. So notice this time I actually did have to draw a new diagram, whereas in the last 2 I didn't have to. So sometimes you do. So root 3 over 2, that opposite over adjacent, by definition of tan. And now we got to be a little bit careful. Since this is a ratio, the tan inverse of it is going to be an angle. So the answer is this angle right here. That rotation produces that angle. The problem is you got to be careful. This is not a 30, 60, 90 triangle because the 2 is not in the right place. It'd have to be in the hypotenuse, which means we can't do this without a calculator. But I set this up to give us an opportunity to show you how to use the calculator to do an inverse. Okay, so this is the one situation where you're going to have to use a calculator because we want this angle. We don't know what it is. That is the answer to this question. It's the angle. We are finding the angle that when you take the tangent of it, you get root 3 over 2. So if we go down here, take out our calculator, we've been doing these in degrees, so you can set your mode to degrees. If the problem doesn't specify, you can do what you want. Tan inverse button is here above the tangent button in blue, so you got to hit the second tan, and then root 3 divided by 2 gives, whoops, syntax, oh, I have an extra parenthesis, 40.89 degrees, 40.89 degrees. Okay, let's finish with one more. So cosine of 3 pi over 2 is in the innermost part of this problem. So I'm going to do that first. Now again, I don't need restricted quadrants because I'm just doing the cosine of 3 pi over 2. Straightforward. Pi over 2 is 90, so 3 times 90 is 270. So that's, or you can see it's 3 90s, 90, 90, 90. So I'm here. So I can't draw a triangle, but what I can do is label that as the point 0, -1 in the unit circle, on the unit circle. And cosine of the angle of rotation is just the x-coordinate, so cosine, so again this angle is going to be, I'm sorry, that's incorrect, this ratio is just 0. So the whole answer is 0. So we're taking cosine inverse of 0. Now, since I'm doing cos inverse, I need to draw my setup, and I ignore those 2 quadrants. And again, I know this is a little confusing because that's a 0. And so the question is that an angle or what's our answer going to look like? Well, remember, we take the cosine of an angle and we get out a ratio. We do the cosine inverse of a ratio and we get out an angle. So this is going to be an angle. Okay, the ratio is 0. So the question now is, what angle when you take the cosine of it gives you a 0? An answer of 0. And again, we can only use any angle that lands in between 0 and pi. Including 0 or pi. Could be one of those. Well, that angle happens to be 90 degrees, right? Because if you rotate 90 degrees, on the unit circle, you'd be going through the point 0, 1, and the cosine would be the x-coordinate 0. So 90 degrees is the angle that when you take the cosine of it, you get 0. It's that angle on the interval 0 to 180 degrees, or 0 to pi. All right, so there's 4 examples of doing these compositions, and just remember, you have all the skills to do it. You just need to sort of combine them all together into one super problem.